Continuing with section 2.3, let us look at another example where we will use the integrating factor method. So remember, we have to have a linear first order differential equation. So the form is often the question given or the differential equation given will not be in the standard form. So we have to first put it in the standard form, and then from there we will start. So remember, the standard form is that we should have a function of x, we can call it a1x, and then first derivative should be multiplied with that, then plus a sub 0x, another function of x, multiplied with y, and then is equal to another function of x. So we don't see our equation in that form, so let's try to see. Now we should have the y separate from x's. So if I will distribute the 3, okay, so now something looking like that. So it's still not in the standard form. We are going to write it in the general form first. So plus 3y, so that is the left hand side of this thing, is equal to, now this is a function of x, so I will move it to the right. Okay, so now I will divide by this x, because that is how we put it in standard form. So standard form we get dy by dx is equal to, dy by dx plus, so we have plus 3 over x times y is equal to sine of x over x squared. Each term will be divided by x, so x will come under each of these terms, this, and that, and of course it will vanish from here because we divide this also by x. So minus 3x. So this is the standard form. What is p of x? P of x is 3 over x, and q of x is sine of x over x minus 3x. Okay, so integral p dx will be equal to integral 3 over x dx, which is the same as 3 times integral of 1 over x dx. The integral of 1 over x is ln of x. So we have 3 times ln of x. That is our integral p dx. So what is mu? Mu will be equal to e to the integral px dx. So e to the 3 ln of x. Now if you recall the property of logarithm, well, we can write it as e to the ln of x cubed. So then another property of logarithm, ln and e cancel out and we get back x cubed. Now I will multiply the whole equation by by this mu, x cubed. So the equation becomes, so this was our equation here in standard form. Let's call it 1. 1 becomes x squared, x cubed dy by dx plus 3x squared y is equal to sine of x times x, so I will write the x first, and minus 3x to the 4. So now we will, well, on the left side here it becomes d by dx of x cubed times y, and on the right hand side we have x sine x minus 3x to the 4th. Therefore, integral d by dx of x cubed y will be equal to integral, well, before we do the integral we have to move the dx. So that we are left with d of x cubed y is equal to x sine x minus 3x to the 4th, and then dx. Now we integrate. So integral x cubed d of x cubed y is equal to integral x sine x minus 3x to the 4th dx. So the left hand side becomes just x cubed y, and on the right hand side, well, the x sine x we will integrate it by using integration by parts. So we have a function x and a function sine of x. So this is how the integration by parts works. We express that we have a function u, and then we have dv, the differential of v. Then this will be equal to u times v minus integral v du. So one of the functions we will let it equal to u, so let u is equal to x and dv is equal to whatever is left. So what is left is sine x dx. Now we differentiate u, so we get du is equal to dx. Find the differentials, and from the differential of v we will find v. So v will be integral of sine x dx, which is negative cosine x, plus a constant c now. So the right hand side is okay, so we still have to integrate it, so it will become x sine dx will be u and v. U is x and v is minus cosine x. We can put the c later. Okay, then minus integral, so v, which is minus cosine x, dv. So dv is du. Du is just dx, which is going to give me negative x cosine x plus sine x. So on the integral on the right side here becomes negative x cosine x plus sine x, and then we also had a minus 3x4, which will become minus 3 over 5x to the 5, and now I put a C. So now we have to just divide by x cubed so that we get an explicit solution. So we can write y is equal to negative cosine of x over x squared, because we have an x on the top and at the bottom we will have x cubed, so it will become x squared at the bottom, plus sine of x over x cubed minus 3 over 5 x squared, because we have x to the fifth and then we divide by x to the third, so we will be left with x squared plus c divided by x cubed. So this will be your solution. So you need to review all your integration techniques. Okay, let's do this IVP problem, solving the IV problem. So we see that our equation is almost in the standard form. So we convert it into the standard form. dy by dx plus 4y is equal to e to the minus x. So that the p is 4 and the q is e to the minus x. So what is mu? Well, here because it is easy, so I'm directly going to integrate here. So integral of 4 dx, which means e to the 4x. That is our mu. So we will multiply the mu with the equation with the mu. So e to the 4x dy by dx plus 4 times e to the 4x times y will be equal to e to the 4x times e to the minus x. Simplifying this, we get mu is equal to, so on the left hand side we get mu times y dy by dx, or d by dx of e to the 4x times y is equal to so on the right hand side this will become e to the 3x. So we separate the differentials, so this gives me d of e to the 4x y is equal to e to the 3x dx. Now we integrate, so integral d of differential of e to the 4x times y will be equal to integral e to the 3x dx, so that left hand side is just e to the 4xy, and on the right hand side we get 1 over 3 e to the 3x plus some constant c, which we will figure out using that initial condition here. So let us see what c is. So the condition is that y of 0 is equal to 4/3. Which means we have e to the 0 times 4 over 3 is equal to 1 over 3 e to the 0 plus c, which implies 4 over 3 is equal to 1 over 3 plus c, which implies c will be equal to 4 over 3 minus 1 over 3, which means 3 over 3, which means 1. So c is 1. So now going back, e to the 4x times y is equal to 1 over 3 e to the 3x plus c, which is 1, so plus 1. Now remember, we have to get y by itself, so y will be equal to 1 over 3 e to the negative x. I hope you guys can understand how I got the negative x, and then plus e to the negative 4x. So this is the solution of the initial value problem. Okay, so now we will look at section 2.4.